need your mics and the headsets for interpretation.
So we do have a mixed participants here in terms of Russian and English. Представлюсь, меня зовут Степан Солженицын.
I will introduce myself. My name is Stepan Solzhenitsyn. I work for McKinsey. And I work there with energy, but not just energy, rather on energy as part of comprehensive urban development. Today we have here the head of the Department of Housing and Communal Services of Moscow that is also responsible for the energy of Moscow, Ghassan Gadziev, who is going to speak about his vision. And we will also speak about some other issues. There will be presentations on behalf of the Russian and foreign speakers. We also have Sergei Sivayev from Skolkovo. We have Lynn Govert from Vito, Belgium, Christina Haverkamp, Managing Director of the German Energy Agency DINA, and Oleg Shutkin from Havel. He's Deputy Director, and he will speak about renewable energy today. Just for the general structure, first we will give the floor to Ghassan. Today we are speaking about the global cities of the future. We are speaking about energy and infrastructure in those cities. Please do share your vision with us. We will later discuss it. Good afternoon, colleagues. First of all, I'd like to thank you for your attention to this subject, because from my point of view, as well as from the point of view of many experts who ensure living in the cities, energy is considered to be a basic issue, and the capacities of the engineering systems determine the whole development of the city, as well as the construction methods and so on. Speaking about energy, I will first divert a little bit from the subject. If you listened carefully to Mr. Sobyanin yesterday and today, he paid a lot of attention to the fact that Moscow is distinguished by a number of factors from the other cities. The first factor that we need to take into account is the fact that for quite a while already we've lived in a different status than the rest of the world. That is why there are some particularities characteristic of Moscow and Russia. Second, Moscow is one of the largest agglomerations in the world. And today, the principles according to which Moscow was developing are different from the other cities. And there are some milestones that we believe are crucial for the life of the city, and these milestones are different from those of the other cities. First of all the engineering systems are centralized, starting from the generation system, then the distribution system. It concerns water, energy, heat, and so on. This is quite unprecedented for the whole world. Over the last years, all the resource generation and distribution systems were significantly changed. Can I get a clicker, please? I'll try to start with the first slide. When it all started, I think no one expected it all to turn so well. I will start by energy generation. There are 15 large stations. You can see the main parameters here. When in 2005 an energy crisis struck us. We had to basically rebuild the whole energy system and the whole generation system. And the first thing done by our colleagues from Mosenergo company was to adopt a serious strategy, a serious program aimed at improving the quality of energy resources. And as a result, the overall picture has dramatically changed. And thanks to those efforts, we managed to reduce gas consumption. Moscow's gas consumption fell from 30 billion cubic meters per year to 22. Such effects are quite unprecedented for all the regions and all the cities and towns. And thanks to that, we saw huge prospects for development. When strategic programs were adopted back then in 2005, 2006, the forecasted gas consumption was measured at the level of 39 billion cubic meters. The transport deficit was quite serious back then, and no one imagined how to implement that strategy. The change in the generation system policy showed that we can unload systems, that we can significantly modernize them, and as a result, we will get a guarantee for the city development. It opens new opportunities for massive civil and construction and other types of construction. It allows the transport development, as transport is one of the largest energy consumers. The next issue that was considered as a very important one on the agenda was transport systems, electricity distribution networks, the creation of transformers, and so on. And these issues were resolved at the same time. And here we can see how transformation capacities were introduced. Over the last 7 to 8 years, the dynamics has been quite active. And we can observe the reserves in energy provision systems that are available today in Moscow. One may ask, do we really need such reserves? But if they were created from scratch, probably it was not necessary. But that reserve became possible thanks to the change of approaches in energy generation, distribution, and consumption patterns. What played also a significant role here is the fact that the construction industry started using energy-efficient technologies. Of course, gas industry followed suit. It also underwent major changes. I'm just going to mention them, and then I will speak about how it impacted our city. Moscow is among the most lighted cities in the world. When we see the dynamics provided by the space workers as they can see it from space, we can see that Moscow is very lighted indeed, and as a result, the level of comfort for the urban dwellers is increasing. There is also architectural lighting, which plays an important aesthetic role. Then, so what followed all these changes? It's developed road construction, developed construction of bridges and highways. The number of bridges and highways increased by 2 times. Regarding the water provision, I'm not going to mention any figures. I will just say that when we get water, then we use it and we return it. And the quality of the water that we return to the water reservoirs is better than the initial quality of water. So Moscow is more than efficient in that respect. And now a couple of words about what was the result of all these changes. Speaking in general about our engineering companies, when we say that we significantly changed the approaches to reconstruction and construction, as well as the materials used, we usually mean that we change the impact of those engineering structures on the comfort of living in the city. And thanks to that, the number of people who worked in the engineering companies reduced by 3 times. If we take Mosenergo until 2005, it employed 25 to 26,000 people. Today they employ 8,000 people. It is significantly lower. It became possible thanks to new equipment, automation, skilled workers, and so on. As a result, we reduced the uncomfortable load on the city. At the same time, there are some spaces covered by the My Street program, and they also changed. Today, we see that the number of electric cables on the street reduced. They all became underground. Everything was reconstructed in such a way so that we don't have to interfere in those spaces anymore in the upcoming 5 to 8 years, even 10 years. So people will not see specialists on special vehicles who are going to dig into something and repair the networks, which will again increase the level of comfort. We also had a uniform lighting program of Moscow, and when we select lighting for the city, we use serious calculations so that the level of lighting is as comfortable as possible. So that's it in a couple of words. If you have any questions, I'll be happy to entertain them. For sure, we will have some questions, but I suggest that first we listen to the other speakers. Maybe our guests could share their experience. And now I would like to address Lynn Gowards. So, what are energy-positive communities? How the transformation of energy supply and energy consumption changes, and how will it change in the future? Lynn, you have the floor. Can we please put on the presentation?
Thank you very much. And as a start, I want to thank the organizers of this exciting forum to have the opportunity to speak here. As been introduced, I come from VITO, which is a research institute based in Belgium, and we are doing research on energy and urban redevelopment. And so I wanted to share some of these insights with you today. I'll do my best to make a good impression, as good as our Belgian football team earlier last week, but I'm not sure I can equal them. So it would be nice to have the presentation.
Если можно, презентацию.
Yes, can we please put on the presentation?
Thank you very much. So, as we all know, the energy transition is at the tipping point, and since 2016, if we look at global new capacity installed, it's more renewable capacity than it has been fossil capacity, and this is new since the recent years. But of course, we know that installing renewable capacity is an easy job to do on an island such as this one. but the urban infrastructure requires much more creativity, innovation, and integration of these systems, as we are in Belgium and also in the nice city of Moscow. We have a quite old infrastructure which we have to renew, and we have to do that in the most sustainable way. So this is not an easy task, and it's a big challenge, for we need all this creativity and innovations. As I said, I come from a research institute, VITO, who together with 3 other research partners joined their forces under the umbrella of Energyville. And we started a new campus on an old mining site in the eastern part of Belgium. And so where in the past on this site they dug the ground, now we harvest the sky, as we call it, and we are developing this whole site to an energy positive site with all the researchers we have. And for that purpose we need to develop new technology and knowledge, but also new services and concepts and business concepts to do so. And we do so in order to support industries, but also policy makers from local to global level. And if you were present in all the presentations yesterday and today, we all know what the challenge is. So by 2050, a large part of our population will live in cities, and they consume most of our resources such as energy, and by such they have a high carbon footprint. But of course, they also have the opportunity, because they are the economic growth and economic power in the cities is bigger if you compare it to the rural areas. So cities are both a challenge, but also an opportunity for innovation. And if you see here, and this is the carbon footprint of a small Belgian city, plotted on a square. So you see to the right, you see the surface of the city, and you see the surface would be needed to offset all the carbon emissions of this city, and this is more or less a factor 5. And this is a typical city of 60,000 inhabitants in Belgium, and as I learned today, you have many similar cities in the Russian Federation as well. And you see the colors, they represent the energy use, the energy consumption of the different sectors, from housing, from transport, from industry, tertiary sector, agriculture, and so on. And this is, of course, a big challenge to evolve to carbon neutral or even energy positive or carbon positive cities if we want to mitigate all these carbon emissions and replace it by clean energy use and so on. But luckily for these cities, we do so, and we do have a mitigation strategy which aims to lower their carbon emissions and make those cities carbon neutral. And of course, if we look at the global carbon challenge, we know that decarbonizing transport and building sector is a very huge challenge. Yeah? So we have to reduce carbon emissions of these both sectors by 95% in order to meet the climate goals that we set up front. And of course, for that we need renewables, and also decarbonizing or having renewable transport and buildings or heating of buildings will mean a big increase of electrification and power use by electric vehicles and heat pumps and so on. So that's why we also need flexibility, because we are evolving from an energy system which was demand-driven in the past, but will be supply-driven by the intermittency of renewable energy sources. And here you see it will be important to capture the value of this flexibility, because we will need all flexibility we have in order to balance the system. And here you see some figures for Belgium, which I learned also is comparable as a city of Moscow when you look at the number of inhabitants. And so in Belgium we have about 200 large industries which already, whose flexibility has a value above 10,000 euros per year. And of course they already use their flexibility in contracts with the transmission operators. But we also have the flexibility of our SMEs, commercial buildings, and the households, which is very small in absolute value per household. But in Belgium, we have 5 million houses, and we should have this flexibility as well in order to balance energy demand and energy supply. So how can we support these households in using this flexibility or capturing the value of this flexibility? And this is where smartness comes in. So we need smartness in the whole system, not only on the system level, on your grid level, but also from the building level. There needs to be smartness in appliances, smartness in designing your buildings, and also smartness in urban planning, because what we see is to integrate the renewable energy in the urban context, we need storage and flexibility, and of course we need to progress a lot in energy efficiency of our houses. And for that purpose, we need a new approach to urban planning, which integrates the energy and climate challenge in our urban energy planning. And for that purpose, we develop tools and we work together with urban planners, because there is no such thing as a golden bullet. There is no such thing as one size fits all for all cities. Every city is unique. And so we have to have this smartness in this urban planning as well. And last but not least, I want to stress that smartness is not a goal in itself, it's sustainability of the goal, and smartness is a way to get there, to have a nice city to live in with providing comfort for all its citizens.
Lynn, thank you very much. One follow-up question, if I can.
Yes.
District heating in a country like Belgium
Yes.
Is present in cities of what size? Only in the largest, only in the most compact, or is it
No.
practically universal?
It's still in the beginning starting phase, but it's being deployed in all types of cities. It's being deployed in new city developments. It's being deployed in cities where they have waste heat that can be recovered in a district heating, and both also in large cities, for example, district heating network in the city of Antwerp, where we've got a lot of residual heat from the chemical industry in the harbor. They are building a heating network, but the picture I showed of this city in the smaller city, they use heat from a waste incineration plant. But we also see new housing development. We see that smart and what we call fourth generation heating networks, which can work on different temperatures with different sources of heat feeding the network, and different consumers on the network are being established. So we see different heating networks of all types in all the cities.
And when you have district heating, presumably that's in effect when you talk about electrification of heat, that would be not applicable to where the district heating is. These are two alternative
Yes.
solutions.
Yeah, well, you can heat, of course, a district heating network. You can heat it with the heat pump as well, and that's, for example, what we're doing on our side. We will, we heat our buildings with heat pumps. We also will use the old mining network, network of the mines underground to store heat during the season. So put hot water under the ground during summer, which we can take again during the winter. And we will connect our network with on the site. All buildings will be connected by a district heating network.
Very good. Thank you so much. Спасибо большое, Лин Ховардс. Будем чуть-чуть чередоваться.
Thank you very much, Lynn Govertz, and we are going to exchange experience, and I'm asking you to, well, I'm addressing the Hevel company, and I have changed the order of the speakers slightly. I would like to hear Oleg Shutkin, the Hevel company deputy CEO. Lynn has set the task for us. Not just renewable energy, but the kind of energy that would also be smart and that will suit cities. So what can we do today? What can the sun energy do today for such solutions for the life of a city, as your presentation goes? Thank you very much, Stepan. First of all, I would like to thank you for the invitation. We are having a very interesting discussion today. Havel is the largest company which works with the solar energy. And this is a full cycle from scientific research to the construction of power stations. We have gigawatts of solar energy, and we have a new product on the market, heterojunction panels, which reflect the entire progress in photovoltaics over the last 50 years. The solar energy has changed. It is different now. What has changed is the efficiency rate of solar panels. Initially it was 10%, and now it's 22%, which is close to the theoretical maximum, which also affects the costs and the areas. The greater the efficiency is, the less surfaces we need. So the applicability of solar panels can be scaled up and can be developed starting from big power stations and finishing with small stations, thanks to the capacity that is only provided by the solar energy. I'll show you an example. Secondly, we reduce costs. The more efficiency, the cheaper is the solar energy. It was reduced from $2,000 per kilowatts of installed capacity to $1,000. And this is a completely different thing. It is very competitive energy, which does not cause any negative economic effects. On the contrary. And the third thing that has changed about solar energy is that it has become universal. It is applicable, not just as individual facilities, but also small applicable solutions. These are flexible solar panels, inbuilt solar panels, which are not an independent product, but which also complement other technical solutions that we are used to. On the right, you can see a special glass package, or actually it's a sandwich panel. So this is a sandwich panel which is united with a solar module, and it costs as much as a usual sandwich panel, but it also generates power. We show this product on various specialized expositions, and this is an example when facade elements are not just a method of building a structure, but also a mean of generating power, which reduces the cost of such structures and allows us to generate nature-friendly energy. We also have lighting with solar modules on Moscow streets, and there are pieces of infrastructure such as benches which are lit with such modules, and there are such modules even in Zaradia. As for what we have already done, there is not so much sun in Moscow. And looking back at the international experience, let's take Belgium or the Netherlands. Actually, the solar energy is developing at a much higher pace. In Holland, for example, there is much more solar energy used, and panels are installed on the roofs, on facades. And as you can see on this slide, there's this hypercube of Skolkovo. It's not far away from here. This building was built just 3 years ago, and there are solar modules with the capacity of about 15 kilowatts, which ensure the exterior lighting of this hypercube. We've already started another image project, a pilot project, the solar Catamaran. And this is a boat which we sailed along the Volga River. It has passed the trip of about 4,000 kilometers, and this boat uses solar modules alone. The heterojunctions solar panels. Those panels are flexible. They have been tested, and this boat uses electric power. It moves with great success, and this is how we show everyone that the solar power, the solar energy industry has changed. It becomes a reliable and a universal source of energy. As for the trend all over the world, the sun energy is getting closer to the end user. Some solutions for households integrate such energy in smart houses, and all life support systems, conditioning, ventilation, all of that is provided by the solar energy. This energy can be transferred into heat, and they are the solutions for the end user, and you don't need any fine-tuning. They are designer solutions. Let's take a battery block. It's not like a battery for the car, but it's an integrated solution which can be used in a living house. And that's how you can make life more comfortable. Our slogan is solar energy for everyone. And we would like Russia, including all Russian households and houses, to start using solar energy as quickly as possible. Thank you. I would like to ask you one precision question, or maybe one discussion question. In the presentation of the city of Moscow, the following thing was said. We are talking about a fundamental need of the city. So this fundamental need is comfort. That's what the city says. And in your case, you have described the solar energy. We can see it. It's very pretty. It can do a lot of things. But what needs does it meet? What needs does it satisfy? It's not just about comfort. Is it just the awareness that we are doing something environmentally good? Why will consumer want this energy? I would call it the energy freedom and energy independence. The solar energy allows us to ensure power where it is needed, without the need to fight for energy resources, without the need to get connected to external networks. You get the energy where you need it, with minimal cost of ownership of a power facility. They are remote solutions, household solutions of great territories, and the solar energy is becoming ever and ever cheaper and more efficient. And of course, this green technology is our priority. And you just can't imagine a technology and an energy which would be greener than ours. So that's energy development in the right direction, in harmony with the environment. Thank you very much. And now we would give the floor to Christina from Germany.
Possible to just also help us a little bit in the Russian context here to better understand at what point decarbonization, which you will talk about, became a fundamental principle. Because in Russia, it's a discussion that hasn't really quite happened yet, or the answer hasn't been let's decarbonize. So in part, you can tell us how you think about cities decarbonizing, but also if you could spend a little time telling us about how society came to decide that it wanted that.
Thank you very much, first of all, for the invitation to this highly pertinent conference, I believe. Second, regarding your questions, may I answer them at the end of the presentation, because I kind of try to focus on the subject topic, and I'm very open to present the political background afterwards. I don't aspire to be as good as the Belgium or the French team, but I hope I'm not going to be as bad as the German team this time. Yeah, the question, the subject matter, cities. In Germany, and I've just learned also in Russia, about 3/4 of the population live in cities. This means that cities are a central player for the energy transition, and that they are a hotspot for greenhouse gas emissions. I've just learned that 30% of all greenhouse gas emissions stem from cities. It's 70%, according to my figures, of all man-made greenhouse gas emissions. So that's a bulk. At the same time, it is often easier to fight greenhouse gases in cities due to the density of the population, the high economic activity, and the services which you can all reach within acceptable distances. And very often these days, city administrations and political leaders have become aware of the challenge of climate change, and they're tackling the problem. I understand that, for example, Moscow, just like Berlin, is a member of the C40 network of ambitious European cities, which aim at making metropolitan areas more sustainable, and that's important. The main challenge these days is to integrate the various components that you need to keep in mind in order to make a city more sustainable, because there is buildings, there is infrastructures, there is energy generation, there's mobility, and you have to combine them all to a coherent system which interlinks. And the challenge is the larger, because for each of these components there are, here we go, there are different options. And the option you take will then influence other components of the system. Just to mention an example that has already been mentioned, when you opt for a high number of rooftop PV, and you want them to feed into the grid. And that's one of our ambitions, to have houses that actively contribute to electricity generation. Then, of course, that poses a challenge to the distribution grid, which you then have to balance. Or there might be an impact of district heating based on renewables, on the usage of your gas infrastructure, and thus on the stability of the system. And because this is so, one very important aspect of energy transition is a holistic and, I wish I could operate this thing, here we go, is a holistic and structured approach. We, as the German Energy Agency, we consult cities both in Germany and also in China. In the meantime, what we see when we go there is that usually they act on an ad hoc basis. They take the measures that they can finance and that look attractive or are maybe modern at the time. But in particular, smaller cities just cannot or are not thinking about a coherent approach. However, that's indispensable. So what you need is first a very clear political commitment by the mayor and by the political parties represented in the city council. What you also need is to establish a competent coordination unit that within the city administration that has the political backing. You need contact points in all the city departments that have to do with energy transition, and basically all city departments have to do with energy transition. You need to have a very thorough analysis of your strengths and weaknesses, of threats and opportunities, of taking into account, by the way, also your financial budget. And then there's the need to draw up a plan that implements a strategy defined step by step. One aspect has been mentioned before, which I find very important, and that is it cannot be done without public participation. You need to consult citizens both on your strategic goals and on every step that is being taken in the process. And that process would be a long one, because no city can afford to transit from today until next year. So that's a point we find quite essential. I would now like to turn to a couple of aspects that are more specific. One is buildings. Of course, buildings account for around 13% of all greenhouse gas emissions in Germany that are direct, and around 30% of indirect greenhouse gas emissions, meaning that we will need to switch to renewable fuels. In particular, that's true for residential buildings, because their heat and warm water is basically the only source of greenhouse gas emissions. However, before you switch to renewable energies, it's a no-brainer, but it cannot be emphasized insufficiently. You need to renovate the buildings. Old existing buildings will lose energy through the roof, through the windows, through the walls, through the cellar. So renewables are a scarce resource, and if you put heating into old uninsulated buildings, it's a waste. Meaning that as a first step, it will probably be easier to introduce renewables into newly built quarters, where you can start from scratch. And as a second step, go into incentivizing the renovation of existing buildings, either by financial incentives or by financial disincentives. The price of gas and oil in particular do play a role in whether or not house owners will be willing to insulate. When there is a coordinated building and supply strategy, several options are there, starting with the direct use of renewables, PV, biomass for less renovated buildings, going over thermal heating, and ending up with an option that we believe is the most attractive for the future, at least for newly built quarters, and that's district heating networks. Because the large advantage of district heating networks is you can feed into them from very different sources, partly fossil if need be, but you can use biogas, you can use waste heat, you can use burning of biomass, you can use large heat pumps, thermal production, no matter what. And heat networks are a beautiful way of storing energy for a long time. Therefore, they also have the possibility to balance out the system a bit. Another, of course, big challenge is that of mobility. In Germany, mobility accounts for 19% of greenhouse gas emissions. Most of it is individual cars, partly it is, or the biggest bulk is heavy-duty vehicles. And if I'm too long, would you please interrupt me? Can I still continue? Okay, I'll be a little shorter. Lots of options, again, biofuels, synthetic fuels, battery electric vehicles. One caveat there, electricity and hydrogen is only as green as the electricity it is generated from. So battery-driven vehicles fed from coal power plants are not as green as they might look at the end of the pipe. How to make things change, fuel quality standards, fuel emission, fleet emission standards are a federal possibility. It's not for cities, but cities still can do a lot. They can reserve areas, for example, downtown areas for green vehicles. They can provide for the infrastructure, very important. They can provide for financial incentives, and when they do so, they should first tackle fleets, meaning taxis, commercial freight fleets, and of course public transportation is a very important sector to act. And you should never forget that part of a green economy is an energy efficient economy, so before you go into the vehicles, you might go into incentivizing the use of alternative modes of transportation, in particular shared transportation. And you might want to invest into digital solutions that make shared traffic a lot more attractive than it is when you need to look for your e-bike after your train has come late and you didn't know it would. And I think I'm finishing there. Thank you.
If you could, though, take a minute on, fundamentally, all of this is viewed as how to decarbonize. Talk a little bit about how society decided that that was one of its goals, because we may have, as we compared approaches of different countries, slightly different goals or functions that we're trying to optimize. Why decarbonize?
I think Germany has always had a very strong green political movement ever since the 70s, 80s, stemming from opposition to nuclear power. Then we have been aware early on that fossil fuels are not endless. Turns out, due to developments in America, they are less endless than one would have thought, but still endless. So those two movements were at the beginning. We had our first energy concept, including a large portion of green energy, in 2010. Then 2011, there was Fukushima, which reinforced our decision to step out of nuclear power. Then came Paris Protocol, reinforcing our decision to also phase out coal. There is no fixed date yet, but it is going to come, meaning that at the same time we are accelerating green energies. Renewables shall have a share of 65% by 2030 in the electricity mix. That's huge.
Thank you so much. И теперь, если можно, обратимся, конечно же, к Сергею Сиваеву.
Thank you very much, and let us turn to Sergei Sivayev. So, in some respects, we are ahead of everyone because we have already what others are developing. On the other hand, we are lagging behind. We are in a complex situation in terms of energy efficiency and other matters. So how do you think, what's the Russian recipe for turning this system into energetic leadership, into a system that the world is looking at and that the world wants to achieve? Is that achievable? Thank you, Stepan. Yes, indeed, the system of centralized heat supply is the invention of the Soviet engineering solutions. They were the basis for creating such a centralized system in countries with large budgets dedicated to it, and particularly in North Europe. And today, we are speaking about the issues of energy in large cities. Here I would like to focus on the issues of heating, first of all. For me, it's not evident that in global cities such as Moscow, alternative carbon-free energy can compete with centralized heating today. First of all, it is due to the high density of consumption, which determines low transportation costs. And second, it is related to the cheap price of gas in Russia. On the other hand, that does not mean that we don't have the decarbonization issue. That issue, I believe, is a matter of enhancing the energy efficiency of the Russian heat supply system. And we have to tackle the issue of decarbonization in that respect. That's a real issue for us. Speaking about what expects us, if we have a look at our payment bill for housing services, it's clear that heating expenses is a basic item there, and often it accounts for 50% of the price. On the other hand, heating in our apartments is an imposed service. It is an imposed service because the consumer cannot regulate it. We can regulate electricity or water, we can turn it on and off, but heating is a different matter. And the engineering solution that is used in Russia, the vertical one, means that we cannot regulate heating in an apartment. We can regulate it only on the scale of building, and also not each time. And I believe that from the point of view of the relevance of the issues that the heating systems are facing, the Central Europe has already gone through this transition period quite quickly. The apartments were upgraded, and the buildings got the possibility to regulate the amount of heat on the scale of the building. So it was up to consumers to decide upon it, not up to the suppliers to impose it. Another solution is to enhance the energy efficiency of our buildings. Today, the main potential of enhancing the energy efficiency in our country are buildings. Residential buildings represent the majority of buildings in our cities. We are not resolving this issue today. Today, we don't have instruments to tackle that objectively. We are not enhancing the energy efficiency today. There are no financial instruments. There is no ways to do that for now. And nevertheless, this is a huge challenge because we ultimately need to optimize the energy resources you use. So consumers need to ensure regulation of heat consumption. It should be dictated by the consumer rather than the supplier. And we also need to create institutions that would help to optimize the energy consumption by increasing the building energy efficiency. Similar problems exist on the side of the supplier. We've seen the figure. It requires serious discussion because when we're speaking about the fact that we have 54% free heating capacity, it is a hot reserve. The question is how much we really need and what do we need to do? It's an open question. What does the world practice tell us? The world experience shows us that the worrying trend related to a big number of capacity supply contracts. The question is, do we need such capacity? The European practice is, of course, cogeneration. It is distributed cogeneration. It reduces transport costs and increases reliability because it all can act as a circuit. So when we're speaking about what we should do on the side of the supplier, we can make quite serious conclusions about what are the structural decisions that we need to take. And should we now restore the obsolete capacities that we have, or rather develop new ones? That's an open question for me. Speaking about innovative things that we have to expect, I think that in the water supply sector, there are no really revolutions. I don't know what can be done in order to bring innovations there. Water is water. We can just optimize pressure, install new pumps, and so on. In this sector of heat supply, we have a lot of solutions. Today, there is no clear alternative, but I participated in a stunning discussion that I liked very much. And in that discussion, we said that, yes, we need to preserve what we have now, but there are ways to use the low potential energy that can be used locally. We can have cold grids, but when we need, we can heat these grids using low potential energy. For example, sewages. Sewages in our houses have 25 degrees, and they are not used today. Such technologies are appearing, and I believe that they can be tapped. I cannot forecast how it will develop, of course, but I think that it might take more than 5 or 10 years. At the same time, in megacities, I believe that we should probably use low potential heat rather than sun and wind. We should ensure secondary use of this low potential heat, and that will benefit our cities. Thank you. Thank you very much. I would like to return to you, Gassan. We have discussed on numerous occasions, and that was also said by the mayor as well as by your colleagues in the government of Moscow. We've been speaking about putting people in the center. What's interesting, what's important for people, that should be in the center. But by your experience, do Moscow residents actually say that they're interested in the subjects that we are discussing? Are they saying that they are interested in energy efficiency? Are they saying that they are interested in what's happening in the pipes, water pipes or electricity grids? Do you really feel their need in expensive solutions such as solar energy? I mean, is what we are currently discussing on the agenda of the Moscow residents? And if not, should we really discuss that? What do you feel? Thank you, Stepan. I would like to highlight that this is a very interesting discussion, and can you please put on my presentation again? First, I'd like to support all of those who are dealing with renewable energy sources today. This subject is very relevant. You always have to engage into research when we speak about energy in general, and the renewable energy is a particular sector that, of course, has a huge impact on the whole energy industry development process. We recall the times when we used filament lamps to light everything. But then the first LED appeared. It was done using spatial technologies, and initially LEDs were very expensive, but then science and industry further developed, and as a result, today 10% of all the light sources in Moscow are LEDs, and this allows us to save a lot. Another matter is the applicability of all the solutions that are developed by research. For me, it's hard to imagine that in Moscow we will have a waste incineration plant just because we need to generate heat. Yes, it does have certain potential in terms of heat production, but Moscow has gone a long path to achieve high environmental parameters, and today 92% of gas consumption in Moscow is represented by the big generation facilities. We have ideal atmosphere if we consider the atmosphere of large cities, and that's crucial. Second, as Sergei Sivayev said, the cost of 1,000 cubic meters of gas in Russia is not comparable to that in other countries of the world. Another important factor is the following. All the energy workers recall with nostalgia times when annual tariff growth was from 14 to 20%. These were happy times. They allowed to feel free. Nowadays, it is 3 to 4%, and we understand that this is lower than inflation. It is all thanks to the fact that we optimized quite significantly all manufacturing facilities and all costs and all production facilities. So when we say that this is significant load, I would argue that we've been working quite seriously in order to achieve that. Speaking about regulation as a subject for Moscow, of course it is relevant, but I would say that it's not that relevant for Moscow. We understand that the heat supply organization is not the legislator. They are executors of rigid norms set in order to respect the sanitary parameters. If we come to buildings and start regulating parameters according to the demand of someone, it will raise legal issues. The heat supply organization doesn't have the right to do that. It is just the executor of the norms installed by the city or the federation. If individually we want to change some parameters or introduce a regulation system in a specific living facility, it should be approved by the experts, and we can indeed cut a part of radiators in a living facility, but we should take into account that the temperature there will be quite different from the standards. Today, Moscow is a very large-scale city, and doing this fine art that will bring the result once upon a time doesn't make sense, because the costs will have to be borne by Muscovites, and no one will allow us to do that. So in the old part of Moscow, we still have the centralized approach. Why? Because today the goal of all the engineers is to minimize the impact on the urban environment. Thanks to that, we are going to be able to improve the quality of the equipment, the materials, and thus reduce operation costs. There is also an alternative that Moscow is about to have. It's new territory. Can I get the clicker? So there is some new territory, the new part, the new Moscow, And there, it wouldn't make sense to implement the old approaches. When we are speaking about the development of various ways of resource distribution, a lot of issues are raised, because how can we implement a centralized approach on such a territory? It makes sense to bring gas or electric energy to the places where developing a heat network would be too expensive. So this is now being discussed by experts, engineers, and companies. And today, when implementing investment projects that are appearing there, we need to ensure the level of quality equal to that of Moscow. So if the regulatory framework today allows us to not to maintain, not to restore the electricity supply in case of a breakdown for 24 hours. In Moscow, we should restore it within 2 hours. These rules are already rooted in our conscience, and we should respect those rules in the new Moscow as well as in the old Moscow. But for the new Moscow, we need new engineering solutions. Centralization is not possible there. We need a redundancy system there, and it should be distributed. And now the matter is, what will be our priority? Are we going to develop the electric economy or the gas economy? This is to be discussed. Let's take Belarus. Today, gas development in Belarus has been stopped because they are using electric heating to cover all their needs, and they are going to follow the strategy until 2035. I would like to highlight once again that the alternative renewable energy sources are very important. We need to work on them to reduce their cost so that they could compare with the actual price of gigacalorie or kVt per hour.
Наше время, к сожалению, на истёк.
Unfortunately, our time is up, but nevertheless, I would like to thank everyone here on my own behalf and add that we can see that all the solutions that we have mentioned from all the countries for all the technologies, every solution has its own place, not necessarily in Moscow, maybe elsewhere, but we still have to learn the lessons. So, what I still need to say, thank you very much to all the participants. These have been quite different approaches. We mentioned various technologies, but we can put that, all of that, in that equation that is called, at the end of the day, maximum reliability with minimum losses and minimal cost of the life cycle. This is what we are trying to achieve in all aspects of our utilities sector and energy sector, and I wish luck to all present.